This webcast is going to talk about how to do the Excel portion of Part A of our capstone project, A Mission to Jupiter. So I am beginning at step 4 when it says that we should start to use Microsoft Excel to make a model of the relationship between the period of the space probe and its altitude above the Earth. And so the first thing I'm going to do is open up Excel, and I'm going to save this with the required file name. So I'm just going to go File, Save As, and let's see, it says to call it Mission to Jupiter, _ section, I'm going to say B, and then your last name. Okay, so I'm going to go ahead and save this. And it then recommends calling this first sheet period versus altitude. So down here where it says sheet 1, I'm just going to do a right mouse click on that and rename it to period versus altitude. That way I'll always remember what this sheet has on it. Okay, now I'm going on, and it says let's make a sheet, a section near the top to hold our constants. These are the unchanging values that we're going to need to refer to as we create our formulas for this for the data table. And so all I want to put there is the radius of the Earth, the mass of the Earth, and the universal gravitational constant. And so I'm just going to come up here to cell A1 and make a little table for our constants. I'm going to need the radius of the Earth, a little typo there, and that's going to be in meters. I'm going to have the mass of the Earth in kilograms. I'm going to have G. I mean, everybody knows what G is. And maybe I'll resize this column just to make it as wide as my data there. And then I'm just going to put my values here. And I can put them in scientific notation. So the radius of the Earth is 6.38 e to the 6th meters. I want this cell to only have the number. Put the units in the description of what this constant is, but in order for me to use this for calculations, it has to be a pure number. The mass of the Earth is 5.97 e to the 24th, and G is 6.67 e to the negative 11th. Okay, so we have our constants here. And you know, maybe just to make this look more like a table, you don't have to do this, but I'm going to just color my header there, and that way it just stands out. Okay, so now I'm going to the next section here, and I'm at step D, and it says let's make our data table. Okay, and we want a good header with the units of measure above each column. Okay. So column A is going to be the altitude measured in meters. Okay, and so I'm going to come down a couple of rows, and this is altitude in meters. So I'm putting my units right there, right? It says that the first value should be 10 million meters, and then we want to make a formula to add 2 million meters to the value in the cell above it. You want to copy that formula down until there are 12 values of altitude. Okay, so I'm going to start with 10 million. 10 million is 10 times 10 to the 6th. And so I'm just going to say 10 e to the 6th. And notice Excel interprets that and puts it in scientific notation. And that's fine. You could go check that just to convince yourself that's right. But 1 times 10 to the 7th is 10 million. And now I want to put a little formula so that each cell below that I add 2 million meters to the cell above. a formula always starts with an equal sign, and I'm going to say take the value in the cell above. And so I'm going to click in that cell where I put 10 million, and notice it starts giving me that cell address in the formula bar. And now I'm just going to say plus 2 million, and 2 million is 2e to the 6th. And look at that, it has added 2 million. Now I can go back into that second cell there, the one that has the formula, and I can copy it down by just dragging it down. I'm going to the lower right hand corner. See how my cursor changes to that dark plus sign? And I'm going to hold the left mouse button down while I copy it. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 maybe. Nope, I went one too far, so I'm just going to delete that last one. Okay, so now I have a column that has a list of altitudes above the Earth, and it starts at 10 million and it ends at 32 million. And that's what it told me to do. It said that the last address, or I'm sorry, the last value should be 3.2 e to the 7th, and that's what I've got. 3.2 e to the 7th. Okay, so now, I'm sorry, my position jumped here. I've created column A, and so now I'm going to go to column B. It says make a formula to calculate the orbital radius of the space probe by adding the altitude to the radius of the Earth. Okay, so this is going to be the orbital radius, also measured in meters. And maybe I need to make this column just a little wider, to hold that title. And so I'm going to put a formula for this. Excel will calculate this radius, so I'm going to start with an equal sign. And I want to add the radius of the Earth to the altitude. Well, the radius of the Earth is one of my constants. So I'm going up here to my table of constants, and I'm clicking that number to get that cell address. Now the thing is, in Excel, when you put a cell address and then you copy a formula, it uses the relative position as where to go. And so if I don't do anything else in this formula, it will always go to the cell 1, 2, 3, 4, 6 rows above where my formula is. But I only have the radius of the Earth at one location in the spreadsheet. So I need to lock this cell down. And so I'm going to come up into the formula bar, and I'm going to put a $sign in front of both the column letter and the row number. By putting those $signs and locking it down, no matter where I put this formula or copy it to, it always goes to cell B2 to find the radius of the Earth. Okay, and after the radius of the Earth, I'm going to add the altitude, which is the cell to the left of where this formula is. So I click over there and hit the enter sign. So what this formula is doing is it's taking whatever's in column B2, that's the radius of the Earth, and it's adding it to the cell that's to the left of where the formula is. And that's okay. I don't want to lock down that cell A8 because I really do want it to use the relative position. It always looks to the left to find the altitude. And then I can just copy that formula down the length of this column. Okay, so we now have a table that has both altitude and orbital radius. By the way, let's save it now. I'm going to do a Control S and save because, save often because Excel does not automatically save for you. Okay, let's go on to column C. For column C, it says this should contain the calculated value of the orbital velocity of the space probe. Okay, it even gives us the formula. It shows us how to, the language that Excel will understand that means the same thing as this formula up here. Okay, so this is going to be orbital velocity. I'm going to put my header here. Orbital velocity, and that's going going to be in meters per second. Just make my column wide enough to hold that title. Okay, so I start with an equal sign because it's a formula. I want to take the square root, and in Excel, SQRT is the function that calculates the square root, and you have to put the values in parentheses that you want to take the square root of. And I need to take the square root of G, so I'm going to go up here to my constant table and click where the G is. I need to lock that down, right? So I'm going to put dollar signs in front of both the B and the 4. Okay, so that's my G times the big mass, the mass of the central body, which is the Earth here. Well, that's another one of my constants. So I'm going to click where I had the mass of the Earth, and and again, I need to lock that formula in by putting dollar signs in front of both the column and the row. And then I want to divide by the orbital radius. And so I'm going to come over here and click in the cell to the left of my formula, because that's where I've got the orbital radius. Remember to close that parentheses and then say enter. Okay? And now that I've got this formula, I can just copy it down to the rest of the to the height of this column. Now, right now I'm showing, it looks like 6 decimal places. I might just want to, you don't have to do this really, but I'm going to format the cells here. So I'm going up to the home format, down to format cells. And I'd like to make this a number with just 2 decimal places. So I'm going to set that as the formatting. Okay. Okay. Now I'm going to go back and let's look at what they want us to put in column D. Okay, it says this should contain the calculated value of the period. And it says that in Excel, you get the value of pi by typing pi, open parentheses, close parentheses. You don't put anything inside the parentheses. Okay, so this is going to be the period, and it's going to be in seconds. Okay, and so the period of something that is in uniform circular motion, and this is a circular orbit, the period of something in uniform circular motion is 2 pi r divided by the tangential velocity. And so I want to say equals 2 times pi, okay, and remember for pi I do pi open close parentheses, times r. Well, r is my orbital radius, so I go over here and click the cell for orbital radius to get that address, divided by the tangential velocity, which is my orbital velocity. So I click in the cell for orbital velocity. So I end up with 2 pi, and then I put in the cell addresses for the orbital radius and the orbital velocity, and say equal. And then I just copy that formula down. Just for appearance's sake, I'm going to make that column a little wider, and I'm going to highlight my header. And you know what? I think it would look easier to read if I centered these. So I'm just going to highlight my table and click the center alignment button. Okay. And so now we have our data table. Okay. I think the next step here is to do a scatter plot, but let's look. It says create a scatter plot of the period versus the altitude. Okay, and so when I look at my table, period and altitude are not next to each other. Altitude is the column on the far left, period is the column on the far right. But when I do a scatter plot, Excel expects the columns to be next to each other. That's okay though, we can get around that. What I'm going to do is highlight Oh, I don't want the header, I just want the numbers. I'm going to highlight the altitudes, and after I've highlighted the altitudes, which is, you know, my independent variable, then I'm going to hold the control key down. So I hold the control key down, and then while I'm holding the control key down, I go over and highlight the column that has the periods. Okay? After I've highlighted just those two columns, I go up to Insert, and I insert a scatter plot. And there is my scatter plot. Okay, so let me add some axes so I don't forget to label this graph. Okay, and so we'll just label this. This is the period versus altitude. And on the x-axis, that is the altitude in meters. And on the y-axis, this is the period in seconds. Okay, and the trend is fairly linear. Okay, so I don't need to linearize it. It's already linear, and so I can go from here to creating doing the linear regression so that I can find my slope and y-intercept. So I'm going to go ahead up to Data and Data Analysis. I want to find regression. Say OK. Remember, the first thing that I want to fill in this form is the y range. I need to highlight the data that's plotted on the y-axis. That's the vertical axis, so that's period. And then I highlight the data that's on the x-axis. That's altitude. And then I definitely want to click the residual plots and line fit plots and say, OK. This creates a new sheet. Everything is compressed when I first look at it, so before I get out of it, I'm going to go to Home, Format, Auto Fit Column Width, and there is my linear regression. Okay.